Good evening, our dear guests, listeners. So today we have the participants who are going to present their reports, their presentations, and we have listeners. And I hope that our listeners will be active. They will ask questions after the reports, and we do hope that today we have an interesting and productive discussion. Today we have a special event, and actually this event became traditional. You know, every year in April, this conference, Student Scientific Conference, brings together first-year master students of the University of Tumen who share their research ideas in different fields of science, whether it's mathematics, engineering, humanities, biology, or any other branch of science. Our session is devoted to computer sciences and information technologies. We have 9 reports today, 9 projects, and our dear speakers will present them. And I think that you will listen to them attentively, and you will ask questions, and it will be a resourceful discussion. I think now I give the floor to our moderator, Valentina Kovylina. She also will say a few words about the time limit and some other aspects which are necessary to know beforehand. Valentina, you're welcome.
Okay. Good evening, dear participants and members of the Commission. My name is Valentina. I'm first-year master's student in the field of mathematical support and administration of information systems. And today I will be the moderator of this event. I'm really glad to welcome everyone to this scientific conference, the topic of which is computer science and information technology. Let me remind you about the time limit for speaking. Your presentation should not exceed 5 minutes, and all questions are asked after appearance. The scientific advisors of the conference today will include representatives of the Center for Foreign Languages and Communication Technologies Natalia Yurievna Filistova and Oksana Petrovna Lazareva. Dear scientific advisors, would you like to say a few words, or can we start dividing our reports?
Well, thank you, Valentina, for introduction. Okay, so I wish all the participants good luck at our session, and I hope that it will be fruitful, productive, and successful for everybody. I think that everybody will find something interesting for themselves and will participate, as Natalia Yurievna said, will participate actively in our discussion. So good luck to everybody. Thank you.
Yes, Oksana Petrovna is my colleague, and she's also the member of the jury, and we are going to assess your reports, your presentations. That is why don't forget about the time limit, so 5-6 minutes, yes, dear students. And don't forget about the main focus, yes, that you should, of course, mention the name of your investigation, of your research, mention all the necessary aspects which we discussed with you at the classes, like methodology, results, and so on and so forth. So don't forget about the structure. And of course, mind your English, try to pay attention to the pronunciation and all these things which we also discussed before. Thank you. I think it's high time for us to start, not to waste our precious time and your precious time. Valentina, will you please present the first speaker, and we shall start our conference.
Thank you for your... Let's start defining the reports, and Anton Borisenko will be the first to speak with the topic predicting the results of measuring a discipline based on a student's digital footprint.
Anton, are you here? Yes, Anton, I see you. So will you please share your screen? Anton, is everything okay with your microphone? We don't just hear you. Anton? So there is no voice. So let's wait for a while. There is something wrong with the microphone, I suppose.
So as far as I understood, Anton has disappeared from our screen. So
yes.
probably he has some technical issues. Maybe we'll proceed to another person and Anton will join us a little bit later.
Yes, I think it will be reasonable. Valentina, who is the next to present the report? Will you please announce?
Okay, next, Kazantsev Dmitry,
Dmitry.
with the topic of development of an automated control system for the information security.
Dmitry? Dmitry, are you ready to start?
There is no sound.
Why? What's wrong? Dmitry, we hear you. So will you start from the very beginning because we didn't hear you at first?
Yes, sorry for this. Good afternoon to everyone. My name is Dmitry Kazantsev. I am a first-year master's student in the field of software engineering and information system management. Today, I want to present to you the results of my work titled Development of an Automated Control System for Information Security. As society becomes increasingly computerized, the integration of computing technology into organizational processes accelerates, presenting opportunities for automation that benefit both employees and management. Despite the availability of existing plugin solutions, there exists a significant gap in the human regional information processing center. That's a government organization that requires an independent self-made solution. System administrators play a crucial role in ensuring the security and efficiency of an organization's information systems. Their responsibilities include a wide range of tasks, and one of them are logging and compiling reports on operating system updates, file operations, hardware configurations, and user sessions. Automation of logging of these entities and report generation is the main goal of the study. On the slide, we can see the key aims of our study. The first one is...
Dmitry, sorry for interrupting, but we cannot see the next slide. Or maybe I have this problem only. Okay, so, well, the slides are not switched on.
Yes, indeed, yes.
Yes.
We switch the slides. Okay. Dmitry, the presentation disappeared. Yes, it's here again.
Because I chose only this screen, but full screen presentation, it's the other screen.
Another screen, yes. So now it's okay. So this is the introduction. Actually, you You were speaking about this part, yes, as far as
Yes.
I understand. Yes. Will you please continue, Dmitry?
Okay. So on the slide, we can see the key aims of our study. The first one is investigating methods for data collection from multiple PCs within the local network. The second one is to develop an automated control system that tailored specifically for system administrators in the Tumen Regional Information Center. And the last one is to optimize administrative tasks and enhance efficiency through automation. The methodology of this study explores two primary approaches for data collection from PCs, centralized and decentralized. The data collection process primarily involves gathering logs from computers, which include the user actions, computer characteristics, and changes to user files. In centralized method, we use one computer, main server, to collect data. Windows server tools are utilized to query event logs and centrally store the collected data. Conversely, the decentralized approach means installing a data collection application on each workstation and collecting more detailed logs. The steps in both methods involve querying event logs and storing the data. In this project, we used a diverse set of technologies. You can see the technologies listed on the slide. We utilized C# and Microsoft SQL Server for the backend, while Electron and React were used for the front-end development. As a result of this investigation, it was found that centralized data collection does not enable gathering the needed volume of information that required for the tasks of system administrator. Therefore, the decentralized approach was chosen, as it allows for the collection of all required information from PCs. Furthermore, we successfully developed the ACS application, which significantly enhanced data collection capabilities and streamlined administrative tasks for system administrators. On the slide, we present the software architecture of our application. As shown in the image, information is collected from each PC and transmitted to the database. From here, the information is accessible on the system administrator's PC and NCS, named Log Monitor, allowing them to review logs and monitor system activity. This slide shows the interface illustrations of dashboard. Here you can see a dashboard displaying events, file modifications, print activities, and PC configuration. Also, there is ability to export this log to table. In conclusion, our study has successfully filled the infrastructure gap by implementing a decentralized method for detailed data collection. We have developed an ACS that effectively automates administrative tasks, enhancing efficiency within the organization. Looking ahead, the project may develop in terms of adding new functionality, more graphs, and informative tables. That's all. Thank you for your attention. Any questions?
Okay. So let us
Dmitry,
ask.
thank you for your report. Dear participants and members of the commission, you can ask any questions you are interested in.
So, any questions, dear guests, students? Do you have any questions to Dmitry Kazantsev? Dmitry, then I will ask a question. Dmitry, what was the most difficult in your work? Which part of your investigation was the most difficult for you to do?
I think it's part when I developed an backend application that collect logs because I never worked with such level of interact with operating system, so it was new for me.
Okay, thank you, Dmitry. Any other questions to Dmitry Yurievich? Probably our students will ask something. Dmitry, is it your new research or you did it for bachelor's degree? I have forgotten.
Yes, it was my bachelor degree thesis.
Research. I see. So this year you have taken another topic, yes, for investigation. Yes, another theme, as far as I remember. Okay. Thank you, Dmitry. So, any questions, dear listeners?
Okay, so Dmitry, I would like to ask you a question. You said that you successfully addressed the infrastructure gap. Yes. What did you do to do this? How did you address the infrastructure gap? Can you specify it? Dmitry, you want to show me what? I cannot hear you.
Dmitry, are you with us? Did you understand the question? Dmitry, will you say something?
You can hear me now?
Yes, yes.
Sorry, sorry, my sound disappeared when I share my screen.
Did you understand the question Oksana Petrovna asked you?
Yes, yes. System administrator usually should collect logs from each PC manually. So my project automates this thing and collects logs from each PC by application. So system administrator can just see logs in one application. It don't need to collect logs manually.
Thank you.
Okay, thank you. Any more questions to the speaker? So if not, thank you, Dmitry. Thank you very much for your presentation. Valentina, will you please introduce our next speaker?
Okay. Anton Brisenko, are you here? Are you ready to show your work, or have the sound problems not been solved yet?
Good evening. Can you hear me now?
Okay.
Yes, Anton, we hear you.
So the next speaker will be Anton Brisenko with the topic predicting the results of mastering a discipline based on a student's digital footprint.
Yes. Good evening. My each of these categories, the student's grades belong to excellent, good, satisfactory, or unsatisfactory. Since the goal is to predict a category or class, this is a classification task. To solve the classification problem, various machine learning algorithms can be used, such as naive Bayes classifier, decision trees, logistic regression, nearest neighbors algorithm, and support vector machine. Four standard indicators are used to assess quality: accuracy, precision, recall, and F measure. The naive Bayes classifier showed an accuracy of 94.5%. The decision trees method correctly classified 100% results. The logistic regression method showed an accuracy of 85.6%. The nearest neighbor method correctly classified 99.8%, and the SVM algorithm was able to achieve an accuracy of 87.6%. The decision trees algorithm has the highest classification accuracy, and logistic regression has the lowest classification accuracy. This study proposes a model based on machine learning algorithms to predict students' intermediate grades. The results show that the models achieved classification of 85% to 100%. The program will help teachers take early action to help weak students improve their results. Further research is planned to use a digital footprint of students to obtain the most accurate prediction results. Thank you for your attention.
Anton, thank you very much. Guests and students, you can ask any questions.
So, students, so do you have any questions to Anton? Anton, as you told that our classes, so it's your new research, yes? Anton, as far as if I'm not mistaken, yes? And so you're doing it just now for your master's degree, actually. Anton, and what else are you going to add, so to say? Is this work finished, or you're going to add anything else to your research?
Sorry.
Anton, just wanted to ask you, have you completed your research, or you're going to add something else?
I'm going to, in future, to create program and after use student digital footprint to predict most accurate results.
And will it be available for the students of Tübingen University?
No, this program is intended for use by teacher of Tübingen State.
Tamara Vladimirovna, you
I wanted to ask, can teachers use in their work just the results of his mastering? Mastering a discipline based on his digital footprint. How a teacher can use it in practice? Anton, can you say us? Can you help us? Can we use the results of your work in our teaching?
Sorry, I don't understand the question.
Can the teachers use the results of your work in our practice?
Teachers can use this program to predict student results in predict students' final grade and it can help I'm sorry.
It can help in what, Anton? What do you mean? So you may just come back to your aim. What was the aim of this project?
The aim of this project is to create a program for predicting student academic performance.
Okay. And what is the value of all this?
Sorry.
The value, ценность в чем?
No, the program will help teachers take early action to help weak students to improve their results.
Okay, yes.
Anton, I have maybe a comment or a question. So as a teacher, I'm very interested in your program. And do you think that teachers of English can use this? And how? In what way?
Yes, other teachers can use this program.
Okay, and shall we assess, the students' knowledge at the beginning, at the start of the course, or when? So how can we find the result? Well, predict, not find, yes, but how can we predict the result of our students? At what stage?
In the beginning.
At
the beginning, yes.
Okay, thank you.
Okay, thank you.
Anton, thank you very much for your presentation, for the report. It was very interesting. If there are no more questions, let's continue. Valentina, will you please present another speaker, introduce another speaker?
And the next speaker will be Kirill Gavinovich with the topic Methods for Dynamic Visualization of Graphs of Educational Students' Results.
Good evening. I can't start presentation.
So, Anton.
Kirill.
Anton is here still. Okay, yes, everything is okay. Kirill, you're welcome. Please, will you please share the screen with us?
Okay. Good evening, esteemed colleagues and guests. It is with a great pleasure that I welcome you to this presentation on methods for dynamic visualization of graphs of educational results of students. Graphs are an important data structure that models relationships between objects. Previewing graphs plays a key role in analyzing data before processing it into an understandable form. Different visualization techniques are suitable for different types of graphs, and the choice of the appropriate algorithm depends on the property of the particular graph. The visualization of graphs plays a crucial role in effectively conveying complex data. Various methods including force-directed and Spring models, have been developed to visualize graphs efficiently. Force-based algorithms such as force and Spring methods are flexible for visualizing graphs. They model a graph as a physical system where the vertices represent charged particles and the edges represent springs. The attractive and repulsive forces between the vertices and the edges determine their location in the final layout. Such methods are often used for simple graphs with the known data structure. The Spring model is a popular physics model for drawing graphs. In this model, the ribs and the springs that tend to their original length when stretched or compressed. When using multidimensional scaling to visualize graphs, a matrix of shortest distances between vertices is typically used as input. In results, 6 types of graphs were each of the graphs worked 14 times on each of the algorithms. During the work, the execution time of the above algorithms was recorded, and the average time value in seconds was determined. Numerous calculations have shown that the difference between the power and Spring algorithms is 20 seconds in favor of the power one. Graph visualization algorithms are not always effective for complex structures. One of the main problems is solving vertices with different degrees of connections. Vertices with more connections often cluster and in the center increasing illumination. Pre-implementation of points becomes impossible due to different sizes and the need for additional information. This creates problems with the readability of the graph. In this work, two force-directed methods were investigated. The main goal of the work was that of the modified methods. It would be most suitable for layer-by-layer visualization of complex transformations of graphs that change over time. Thus, based on experiments, it was concluded that the force method of the force-directed method is more reasonable. That's it. Thank you for attention.
Thank you very much, Kirill. Anyone can ask a question?
Okay, so Kirill, probably I will, so everybody will think about the questions. So you're a specialist in this area, and so probably you're interested in this, and maybe you will comment, you will ask questions. Kirill, I have one question. So it was a kind of experiment you did, and when can we use? Can this use? Can it be used in everyday life, for example? Where can you use it?
I guess no, in that more scientific research and maybe that using for some another scientific works.
Just for drawing graphs?
Yes.
Thank you.
Okay. Any questions to Kirill? So students, you're welcome. Don't forget to ask questions. You're supposed to listen and ask questions. So it's connected with your specialty, with your profession. That is why you are experts on all these questions. If there are no more questions, thank you, Kirill, for your presentation. Let's proceed.
Thank you.
Okay, I will be the next speaker. So let me 1 minute. Sorry. Okay, I can start. Good evening, everyone. Again, today I want to present the work, development, and research of algorithms for video generation based on diffusion models. At the moment, there are many generative models that are successfully used in various creative fields. But the most popular area has become the study of approaches to video generation based on text and video reference. Creating such tools will help you easily create, process, and edit video content, even for those who don't have special skills, or will become a great assistant for real professionals. However, previous works, for example, Tuna Video, created by scientists from Singapore, has shown that video generation is associated with many problems that lead to video distortion due to frame inconsistency. A change in the standard diffusion process has been proposed as a solution to this problem. Based on this, the aim of the study was to develop such an algorithm for generating video based on text and source video, which will achieve a lower level of inconsistency compared to existing approaches. The first stage of the work was to study the structure and principles of operation of diffusion models. The models mainly consists of a forward and backward process. First, the original image is by step distorted by adding Gaussian noise, and then the final image is predicted using vectorized text. Next, the disadvantages of existing approaches were identified, based on which a new generation method was created that separates the residual noise needed to create an image into true and binding, where the binder carries information from already generated frames. An inversion algorithm based on the neural network UNet was also implemented. Both methods combined the increase the connection between the source and the resulting video, as well as between bordering frames. To evaluate the created model, 42 videos from the Davis dataset And following previous work, the Fouché video distance was used to compare the results, which is sensitive to both static and dynamic noise, as well as three metrics to assess the similarity of the generated and original video, the accuracy of editing, and the temporal consistency of frames. Based on the quantitative results obtained, the created algorithm increases consistency compared to frame-by-frame generation, and the results of its application are comparable to current video editing methods. A visual comparison of the generation results with current video editing methods was also carried out. The resulting method is also applicable to various video editing tasks, such as stylizing and changing objects in the frame. So, generative models have almost unlimited possibilities for creativity, and as mentioned earlier, researchers in various subjects areas are adapting the use of such networks to create images, audio, video, and other content. This work reveals the possibilities of video generation using a model original trained to create images. This can be a motivation to further explore the potential of diffusion models to learn and interpret the visual representation of the world. Thus, based on the aim of the study, in the course of work, factors affecting frame consistency in video generation based on text description and video reference have been identified. Implemented text and video to video generation based on the image generation model, and the results obtained were compared with the results of analogs. That's it for me. Thank you for your attention.
Thank you very much, Valentina, for your report, for your presentation. Any questions, dear listeners, students, the members of the jury, guests? You're welcome.
So we have a question in the chat from Oksana Borisovna. Okay, Valentina, this is the question for you. So first of all, thank you for your presentation. And the question is, what is the aim of your project? And do you know other researchers of your topic?
The aim of the study was to develop a new text and video to video generation algorithm that allows you create videos with less inconsistency compared to existing approaches. And what about other researchers? I
Can we prove?
sorry.
To prove unseen elements of the act. Unseen elements of the act. To prove.
Tamara Vladimirovna, will you switch off your mic, please?
I would like, it's very, very interesting. I would like to ask her, is her paper just can prove some unseen elements of the act? Yes? Can this paper, can it prove, доказать? Can her paper prove some unseen elements, которые мы не видим? Can her paper prove, доказать unseen elements of some acts. How do you think, Valentina? It's very interesting paper. Can you prove something interesting? The person and
Sorry for the sound. I didn't understand the question well.
But you've said you show some slides and sometimes people don't see something interesting, something very important. But in the slides, you can see it and you can prove some interesting facts that people's eye don't see. Understand, Valentina?
So probably it wasn't the aim of Valentina's project, Tamara Vladimirovna. Okay, so and that's why it's difficult to answer. Okay, so this well, the aim of the project is to prepare to train a model to create different images. Am I right, Valentina? Yeah. So to well, the images to be precise, and this is it.
Okay. Thank you.
Valentina, so probably Valentina is not Anya. Valentina is here, is still here, and we have some more questions in the chat. Valentina, can you see these questions? Okay, so Dmitry Milutin, thank you for your presentation, and the question is, how much faster does your solution work than others? To what extent is it faster than the work of others? Valentina, are you with us? So probably something happened.
This solution works better than some works, but is inferior on but is inferior in performance. But also this work can be comparable with top neural network in this field.
Well, okay, Valentina, I see that probably it's difficult to answer the questions, yes, so the questions are not so easy. So nevertheless, or probably you are nervous a little bit, I'm sure that you know perfectly well this the topic you're talking about. Probably I also ask a question. Of course, we are all interested in practical application, yes, of your work. And my question is, in what fields or professions would it be useful to use the video generation you talked about?
I think this will be really useful for all professions related to video creation and editing. Nowadays, there are a huge number of social network. Everyone actively uses the internet, and video content always attracts more attention than a static image. Therefore, diffusion models of video generation will be useful to almost everyone. I think especially for bloggers, video editors, and maybe filmmakers.
Okay, thank you very much, Valentina.
Thank you.
So, any more questions to Valentina? If not, we are going to continue our session. Okay. Valentina, can you introduce another speaker, please? You have the list of speakers in front of you. Will you please?
Okay. The next speaker is Arseniy Peregrimov with the topic of development of a service for identifying in-demand groups of specialist skills based on job vacancy texts.
Okay.
Can you hear me? Or not?
Yes, Arseniy, yes, we hear you. We don't see the presentation. Will you please share the screen with us?
Can you see screen?
Yes, now we see the screen, we hear you. You may start.
Good afternoon. The topic of my work is the development of service for determining the in-demand skill groups of specialists based on vacancy text. The problem of my study is that to understand which groups of technologies are relevant in the IT labor market, people looking for work need to review many offers manually. To solve this problem, it is necessary to identify these groups systematically. Since the criteria for relevance may be different for each person, we also need to provide the user with the opportunity to choose these criteria independently. This study checks it is possible to solve this problem using clustering algorithm or not. During the work, the following stage was said. Conduct an analysis of text clustering approaches in context of our problem and develop a method of correlating groups of actual skills with student skills. On this slide, you can see math statement of the problem. We have a set of vacancies. Each vacancy from the set is assigned a vector consisting of the skills encountered in this vacancy. It is required to divide this set into clusters. Each cluster should characterize a particular IT area. The following clustering algorithms have been studied. Next, I will talk about the algorithm with the help of which it was possible to obtain a meaningful result for this problem. First, comments. When we using comments method, we must specify the number of clusters into which object will be divided. To find the optimal number of clusters, the elbow method and the silhouette method were used. On this slide, you can see plot for elbow method. The best case will be the one at which the curvature of the plot is maximum. This is plot for silhouette method. The optimal values of k are located at the point of local extremum. Comparing these methods, you can see that the optimal k in this case will be 10. On this slide, you can see examples of resulting groups. K-means identified cluster that characteristic areas as well, but some clusters turn out to be so general that it is difficult to understand a specific stack. To train a DB-scan model, you need to set the following parameters. Epsilon distance from the core to the external object at which the external object will be considered part of the cluster and min samples define the minimum number of objects required to form the cluster core. Since the vast majority of vacancies contain no more than 30 skills, min samples parameters set so that are no more than 30 skills in one group. Epsilon will be selected using a heuristic method similar to the elbow method. The most appropriate epsilon values will be at the point of maximum curvature. In this case, optimal epsilon value between 0.5 and 0.8. On this slide, you can see examples of the resulting groups. The Buscan identified clusters of highly specialized stacks. But in some cases, there are few skills left in group, not on this slide. This is best when we can get from this method. And the Buscan characterizes the specific IT area. This group show an aural specialization. This flowchart describes the algorithm for selecting groups that are relevant to the user. The user sets the relevance parameters, such as salary, region, and skills. If there are suitable groups, the user's skills are converted into vector numerical form. For each matching group, a centroid vector is calculated. The distance is calculated between the user's skill vector and the group centroid vectors. Groups with nearest centroid vectors are displayed. In conclusion, we can say the following. K-means identified clusters that characterized with IT field as a whole. DBuscan good for clusters of highly specialized stacks. Mean shift and agglomerative clustering is not suitable for this task. Using clustering algorithms to figure out which skill groups are in demand makes sense when we're talking about K-means and DBuscan algorithms. In next researches, it is possible to study the performance quality of other clustering algorithms when solving this problem. That's all. Thanks for watching.
Thank you very much. You can ask any questions.
So who would like to ask Arseny about his research?
I don't have a question, but I would like to say that this really good presentation can be used by some teacher for teaching ML methods for clustering. Really good. I like it.
Indeed. Thank you. Who would like to ask one more question? So if there are no more questions, I think we shall continue. Arseny, thank you very much for the presentation, for your report, for the research you presented. It was very good. Valentina, who is the next speaker today?
The next speaker is Renat Bulatov with the topic Knowledge Graph Application Surveys to Support the Determining Topics of Education IT Projects.
Good evening. Can you hear me?
Yes, Renat, we hear you. We see the presentation. You can start your report.
Any seconds. Did you see slide?
Yes, we see the slides. We hear you. Yes.
Good evening. My name is Renat Bulatov, and the topic of my work is knowledge graph application service to support the determining topics of educational IT projects. In recent years, project-based learning has become popular in education. Information technology is no exception. It may be difficult for students to decide on the topic of the project, as well as the choice of an advisor, because they may not know about his experience and scientific interests. The definition of the topic is an important stage of the project, since the quality and effectiveness of the growth of student competences depend on it. The project's objective is develop a recommender system for determining the topics of educational projects using information technology knowledge graph. The topic of IT project can be described through the methods and technologies used. The service uses Wikidata as a knowledge graph to determine the semantics between methods and technologies used in projects. We use Wikidata entities to represent methods and technologies and call them descriptors. Descriptors are used to describe the topic, the interests of the student, and the teacher. A set of graduation papers was used to determine the scientific interests of the teachers. A data set with annotated scientific terms was also used. With its help, a model for recognized terms will be trained further. The term extraction algorithm consists of several stages. First comes the extraction from the document, then the recognition of the terms in the text, and the search for the term in the Wikidata knowledge graph. To recognize terms, several neural network models were trained on a dataset with terms. After evaluating the quality using metrics and comparing it with the baseline, the Rusai-Bert model showed the best result and was used in the final version of the service. Each recognized term was used in Wikidata, and among the search results obtained, the one closest to the context of mentioning the term was selected. If the found Wikidata entity is related to information technology root terms, then it's used as a descriptor. For example, the slide shows the result of extracting descriptors from a gradation paper. Programming languages used tools and machine learning methods were obtained. In the service interface, the student can describe their interests using descriptors and find the most suitable academic advisors indicating their interests. In conclusion, as a result of the work on the project, a service was developed where a student can indicate his interests and find a topic and scientific advisor, taking into account his previous experience. He can use synonyms or similar terms and find relevant results using knowledge graph. The algorithm for marking documents and presenting them using knowledge graph can be used in other projects. Search and clustering of documents, analysis of the coverage of the subject area by scientific works. Used references are presented on the slide. That's all. Thank you for your attention.
Thank you very much, Renat. Please ask questions.
I have a question. Can your work be used in websites for job employment, like Headhunter or Avito or something like that?
I think yes, because the using the semantics of using the semantics that provided by knowledge graph, we can use fuzzy matching of skills and if person who try find a job can be described described their skills without exact matching and can find job with similar skills.
Yeah, thank you.
So there is one more question in our chat, Sergei Stolarov. How did you choose the root terms of information technology to build the knowledge base? Another question.
The root terms were selected manually. We looked at random terms and based on these ancestors, we determine the root terms for information technology.
Thank you.
Any more questions, dear listeners? Our guests probably have questions. Students. So if there are no more questions, thank you, Renat, for your excellent presentation. It was very interesting. Thanks a lot.
Thank you, Renat. And next will be Denis Dmitriev with the report, development of a system for searching anomalies in indoor air temperature time series.
Good evening, dear members of the conference and guests. Can you hear me?
Yes, Denis, we hear you. We see your presentation.
My name is Denis Dmitriev. I'd like to present you my work, development of a system to search for anomalies in time series of indoor air temperature. This study is devoted to the problem of identifying strange behavior of heating systems of smart houses equipped with Internet of Things technologies. Such problems can be caused by faulty or damaged equipment, so their timely detection is necessary. Traditional methods to solve this problem include statistical and machine learning models, but the aim of this particular work is to showcase the effectiveness of neural networks in this task on par with them. A little words about that data. Temperature data was collected from Tumen State University classrooms, recorded at 10 minutes intervals. At this slide, you can see the architecture of the program. Software was developed to carry out the research work. It conducts experiments by preprocessing, training models, and detecting anomalies in time series. The first step of our work was the given definition of anomaly. It was decided to divide anomalies into three types: point anomalies, group anomalies, and context anomalies. For our task, the definition was taken from a similar article. Temperature anomaly, a subsequence that makes graph asynchronous, sudden spikes and drops that change the air temperature in the room. Models were assessed using the ROC, precision recall, F-measure metrics, and the time resources involved for training. At this slide, you can see a system interface. It contains all necessary parts for entering data, loading time series, showing temperature graph, displaying information about the operation of the model. We began our study with analyzing statistical methods. In our work, it represents by Sarima autoregressive model and Holt-Winters method. Models were optimized using Akaike criteria and Newton's truncated method, respectively. In the vast majority of cases, you can see that forecasts made using by Sarima method are more accurate than forecasts made using Holt-Winters method, but it takes too long time to work due to hourly seasonality that we have in our data. The next group of model that we studied in the research were machine learning models, represented by models based on gradient boosting and isolation forest. We used cross-validation to find the best hyperparameters by maximized AUK function. The ones left below on the slide, the ones that provides the best performance. Based on the results obtained, we can conclude that models based on gradient boosting cope better with task of finding anomalies. Of all models, CatBoost showed better prediction accuracy and faster learning process. And the last group of models that we studied was deep learning models presented in study of models recurrent neural network, LSTM, and generative adversarial networks for anomaly detection, TADGAN. Models architectures were taken from articles where these models were used to find anomalies in time series. Of 3 models, you can see TADGAN showed the best result. We compared all models for all audiences. According to the result of the study, deep learning models showed the best results among all presented groups of models. TADGAN outperformed all baseline methods by having highest F-measure score, 68. It was also tested how different models find different types of anomalies. Based on the current results, it can be concluded that gradient boosting models cope well with point outliers and group anomalies, but are not able to accurately determine anomalies caused by long-term trends or technical patterns. Neural networks models are usually better at dealing with the local anomalies that occur with some periodicity. However, contextual anomalies such as trend changes are less clearly recognized. And autoregressive models cope better with anomalies that have clear patterns and also work well if the time series graph is stationary, but cope much worse with outliers that do not have clear repeating patterns. As a conclusion, I must say that we did a comparative analysis of machine learning models for searching anomalies in time series. Based on the results of the study, it can be said that despite some gaps in the search of contextual anomalies, neural networks can be used to solve this problem on par with traditional statistical and machine learning models, at least in combination with them. The results of the study can be used to build a system for identifying problems with the heating systems of smart houses to improve the reliability, safety, energy efficiency of the system, and improve decision-making processes. Thanks for your attention.
Thank you very much, Denis. Please ask questions about the report.
Okay, dear students, don't be shy. Don't hesitate to ask questions.
Can your work be used in the fire sector? For example, make some signal to fire station in some really external anomalies.
I guess it's how the heating system, at least systems of the smart houses should work. Our work aim is to find some problems with equipment, I guess. So if the equipment is broken, it can't make some signals. So our task was suggest some systems that can help find these problems with equipment.
Thank you. Thank you.
Okay, thank you for the question and for the answer. Any more questions to Denis? So do we have any questions in the chat? Let me check. Okay, no questions to Denis so far. Thank you, Denis. Thank you very much for your speech, for your interesting ideas, creative ideas. So thank you. Valentina, let's continue. Who is the next speaker?
If there are no more questions, let's continue. And the next report is font recognition using AI, And the speakers will be Расим Газизулин и Александр Ершов.
Good evening. And before we start, I would like to ask everyone to turn off their microphone, please. And okay, we can start. I will never forget how a client asked me to find a font that I had never seen before. This was the reason for creating an AI that detects fonts. Moreover, designers in our planning have the same general problem, namely finding necessary fonts. This situation arises when a client asks to add a font from a photograph without having its name, or to redraw any layout, or to change the text using the required font, but its source file were lost for some reason.
There is origin site with the name What's the Font for this purpose. How it works? A photo was uploaded to the site, after which the site recognized the font and displayed a number of similar ones with links to purchase and download the font. Disadvantages of this solution: at the moment the site is blocked in Russia, entry is only possible using third-party services. Also, the service recognized only Latin fonts, which absolutely does not solve this problem with Russian Cyrillic fonts. Our task to study the working methods of such a system and in the future to create a website with functionality for use in Russia. Today we will show you a test case based on Adobe Deep Font development.
The first thing we started with was training the model. The training plan for the model is extremely simple. We download fonts from various font APIs on the internet, in our case Google. Using the API, we build several different images with a certain font, with different backgrounds, with different letters, and so on. We perform this process for each font. At the heart of the neural network, we have an ultra-precise neural network. The input is the image generated by us in the form of tensors, creating the final vectors of embeddings for each font. Next, to guess the font, the image is also converted into vector embeddings. After this embedding is compared with others to find the closest one. What are the problems? At this stage, we do not get very high accuracy, which is due to the small number of fonts in the trained model, but the main problem is a small augmentation. The augmentation we need had the ability to recognize fonts from different angles with effects and changes. Thank you for attention. We hope to show you a fully working website soon. We are ready for your questions.
Yeah. Can you remind, please, where it can be used?
The question was...
It can be used in design sphere. It's very helpful and useful for designers all over the world. If they want to identify the font, the name of the font, but they don't know exactly what's the name of it.
Oh, yeah, agree. I also think that it can be used in intellectual or property rights. Yes, for business or for law. Yeah, thank you.
It also can be used in printing houses, printing shops, where people go and want to print something, posters or something like that.
Yes, as example.
And we have a compliment and a question in the chat. So, Rasim, Alexander, your English is very good, and thank you for your presentation. So, Oksana Borisovna wrote, and the question is, how long does your research last, and how do you use your research results? Who would like to answer? Rasim, Alexander?
1 minute. Our research long about half of a year, and now we can't use it because we have low accuracy, and we're working now to develop the score of accuracy. So this is we're now in the process of developing.
Okay, thank you. And so you don't use the results of your research yet because they're not ready. Yeah?
It's ready, but for simple fonts.
I see. Thank you.
Okay, any more questions to our speakers?
If there is no questions, I would like to wish good luck to next member. Thank you for attention.
Thank you very much, guys. It was very interesting.
Okay, thank you. Let's continue. And the last one report is automatic detection of room types in 2D drawings. And speakers will be Vladislav Sanduyan и Всеволод Волчок.
Good evening, everyone.
Yes, hello, we are here. So, is it all right with my demonstration of screen?
Yes, we can see.
Yes, we see the screen, we hear you, everything is all right.
Okay. Our team, consisting of Vladislav Sanduyan and Всеволод Волчок, would like to make a presentation on the topic of automatic detection of room types in 2D drawings. Have you ever had to imagine a picture of a room and did not know how to draw the plan? Our research will help you. In our opinion, automatic detection is important not only in building area, but also in private life. The goal of our study was to develop a neural network for automatic detection of room types in 2D drawings, using deep learning to enhance the efficiency and accuracy of architectural project analysis. The objectives were the first to collect and prepare data, the second to train the model, and the third to test and evaluate the model. To achieve the above goal, the analysis delivered on this topic. The analysis covers a wide period from 2012 to 2022. This analysis helped us to structure and complete the study. As you can see on this slide, we have a data set of 800 images of various types of apartments we have collected. And we also have marked up about 5,000 types of rooms and them. And for training, we have divided data set. We chose 70% for the training sample on which we trained the YOLO V3 model, and 30 for the rest test sample. And the slide also shows a graph illustrating the reduction of neural network error in the learning process.
As a result of the training, we conduct tests on 30% of the sample and got very good results. They show that our model determines the types of rooms with 95% accuracy. This allows to prepare accurate and clearly drawing of a room for further use by neural networks. This slide shows the result of neural network operation. In this case, the neural network has identified all types of premises with 100% accuracy. We're happy to achieve this. And in conclusion, we would like to say that our team developed a neural network to automatically determine the type of rooms in 2D drawings using by steps we have already mentioned. It could be available to various industries and individuals, for example, architects, smart home automation companies, or educational industries. We are not going to stop here. Our plans for future are to continue trajectory of studying the work of neural network with 2D drawings, namely to conduct two studies: automatic furniture placement on 2D drawings and automatic 3D modeling on 2D drawings. This can help interior designer to work faster and the buyer of apartment to see how the chose design will look before we start repair work. We encourage everyone to explore potential of deep learning in architectural analysis and real-time determination. This way, we can utilize the entire room area rationally and reduce the number of mistakes even before the renovation work starts. Thank you all for your attention. We are ready to answer any question you may have.
Thank you very much.
Yeah, I have one question. Can you repeat where you find this dataset? Because this problem quite actual and common in sphere of real estate, and every developer have own standard of these images, and get a universal algorithm for this problem. It's quite difficult.
Yes, thank you for your question. It's a really problem, and that's why we use and collect dataset from different types of development websites. For example, like Etagy, Metrics, and another one. Most basically work in Tumen, but also in Moscow, in St. Petersburg. That's why our datasets is really whereas with these plans, with types of these plans.
Thanks.
Yeah, thank you for your question.
Another question is in our chat. Stolerov Sergey is asking, why did you use the YOLOV 3 model if there is a YOLOV 8?
Oh, yeah, thank you. For our research, it will be more easier to use YOLOV v3 model because this model have a lot of documentation of examples in the internet. That's why we start with this model. And we have in plans to retrain our dataset on the YOLOV 8 model and compare results, and maybe it will be on our conference, who knows.
And one more question for you. Why do you have a gap in the error graph?
Oh, yeah. We train our model for 8 hours, and because of some technical necessities, we need to stop it and make a save in backup. And that's why we train in 2 steps. That's why we have gap in our graph. But it don't have any bad influence on our model.
Thank you. Any other questions, dear listeners?
Dear students, do you have any questions to our presenters?
Yes, there is one. Yaroslav Shensov, what type of data did you use for the data set?
Thank you for your question. We used JPEG images as Vladislav said, that was posted on the websites of real estate agencies.
Okay, thank you for your questions. Thanks to all the participants and guests of this conference. All the works were very, very interesting, and I hope they will continue and improve in the future, and will definitely find their users. The results of the conference will be ready this Friday, April 12th. If anyone wants to speak out, you can do it now.
Thank you, Valentina. So, dear participants, our guests, students, do you have any comments? Do you want to say something? Which report did you like most of all, probably? Well, I
So
suppose.
may I begin, and maybe somebody will join me. So I would like to thank all the presenters. I'm very impressed by the knowledge of your topics and, of course, the knowledge of the language. As a teacher of the language, I was very pleased to hear your presentations. Thank you for the audience as well for listening at least and for asking questions, because I think at the end of our session, the audience became more and more active. And thank you for asking questions, for your interest in the topics. And I would like to thank Valentina as our moderator. Valentina, thank you very much for structuring and organizing our meeting today. And I hope that everybody enjoyed the session and found something interesting, maybe even something new. And I wish everybody good luck in your further research and getting knowledge. Well, thank you very much.
Thank you.
Goodbye.
Thank you too.
Thank you, dear students. Actually, we have to consult with the members of the jury. That is why, if you want to say, if you want to comment, you're welcome. Probably you have got some questions to ask. If not, we will inform you about the results on Friday, as we planned. So that is why thank you everybody for your creative ideas. So your presentations were very up to the mark, I would say. So we listened very attentively and with pleasure. We learned some new ideas. And you're very smart and brilliant students. Thank you very much.
And just a reminder, maybe, so you can leave now if you don't have any questions or comments, but we are waiting for you on Friday as a wrap-up of our conference, and it will begin at 5 p.m. Don't forget about the time, please.
Okay, thank you.
Okay, thank you everybody one more time. So if there are no more comments or questions, so students, you may be free. So we need time to discuss all your reports.
Okay, goodbye, everybody. And
Okay,
see you on Friday, and see your own lessons. Yeah.
Yeah, sure.
If you have any questions, just write.
Thank you. Goodbye.
Valentina, thank you very much. Goodbye.
Okay, goodbye. Thank you.
Goodbye.
Tamara Vladimirovna and Oksana Borisovna, will you stay with us, please? Just for a little while.